Alright, I think we're live right now. Alright, perfect. Alright, welcome to this little code with me kind of thing. So I'm a computer science student in the university, and I guess let's go ahead and start coding. Okay, so basically, I'm from the C family of languages, and recently in the university we've started learning about Java, more specifically not Java as a language itself, but the concept of object-oriented programming. So that's what we're going to try to do today. So we're gonna do a very simple kind of a very simple example of what object-oriented programming can be done with, or like what we can do with it using Java. So what we have here in front of me, okay, this is alright, this is Lucidchart. Okay, I am not promoting Lucidchart or like sponsoring in any way, but basically Lucidchart is a charting tool, or a tool we can make some charts with. So for this specific application, we're going to create UML, which is Unified Modeling Language, if I'm not mistaken. So basically it's general. It doesn't have to be, it's not Java specific, but as long as it's object-oriented programming, correct me if I'm wrong, but I think this is how it works. As long as it's object-oriented programming, then pretty much, yeah, as long as it's object-oriented programming, it's pretty much how it works, or how we can design, because it's important that we have to specifically design our code before we start coding it, because it's going to be better to see some issues now. Okay, it's way better to see issues now rather than have to deal with these issues when we're already partly finished implementing our code. So that's not what we want. Okay, so that's kind of that's a tricky thing to deal with, especially when you have when you notice a problem wherein you'd have to rewrite a heck ton of your code, which is not ideal. Okay, so this is where we're going to try and conceptualize and think about everything that we might need in the program, so we don't have to run into different issues later on. Okay, now let's go ahead and set up our Lucidchart. So again, Lucidchart is it has a free version, but it keeps telling you to buy it. But so let's set up Lucidchart. So let's remove all of our existing diagrams here on the side for now, and let's add some shapes. Okay, if you notice down here we got UML. We want to expand this, and for our current application for today's topic, we're just going to use the class diagram, and which one was it? Yeah, just a class diagram for this one. So we're going to use these set of shapes. Alright, so for this specific thing here, for this specific application, I'm just going to create a new document here, or a new text file, and zoom that in so you can see it better. So for this application, or for this practice session, what we're going to be using, or what we're going to be doing, is a simple problem here. We're going to try and create an entity or an instance of every classroom in a school. Okay, so we have classroom. Okay, so in each classroom there is a student. Okay, and each student, maybe we can make something like I don't know, the student has its name, of course, or the classroom can have a name. Yeah, okay, the student has a name, the student has grades, let's say, group of friends. Why don't we can say something like that anyway. And or better yet, what we can have here is a list of subjects, and under the list of subjects we have the subject name, and we have our grades for each subject. Okay, so we have the grades for each subject right there. Alright, so let's try to implement maybe a simple program like this. Okay, how about let's also add a teacher here, and maybe in the classroom homeroom teacher. Just something for object-oriented planning here. Okay, why not? Let's go with that. Okay, let's save this to problem.txt. Okay, Let's go with that. Now let's get back to loser chart here. Okay. All right. So, basically, let's get into the basics of the UML first. So this is your standard class diagram. This right here. Oop, not too much. All right. So you have your class name on top here. So let's call this my classroom. Or, classroom works fine. Okay. So what we have here, these inside the first box right here, these are actually variables. Okay. They can be almost anything. They can be instance variables or class variables, which I will get into detail later on. Here we have our methods. Okay, we have the class methods. We have our constructors, which are listed here. Okay, now let's try and design this class. If we're going to talk about a student or a classroom rather, we have a name, the classroom name or the section name that's assigned to that specific classroom. We have a homeroom teacher, and we have a list of students. Okay, and then within a single instance of a student, we have the student's name. We have a list of subjects, which has a subject name, grades for that subject, and the teacher for that particular subject. And of course, why not add in some group of friends? Okay, so let's try to tackle this problem here. Now, as you can see, just a little run through here. We actually have in Java, or at least in object-oriented programming, we have things called access modifiers. And access modifiers basically, gives you the scope of each method. Okay, so for those of you that don't code with Java or any object-oriented programming language, method is basically a function within a class. Yes, so we're trying to develop a class here. Okay, not class as in the classroom, but class as in a Java class. Okay, so as you can see, we have a plus icon here, or a plus character. So the plus character here denotes what you call a public variable if it's here, and a public method if it's down here. Okay, then you have your private ones if they're denoted with a dash or a hyphen or a negative sign, whatever you would like to call it. And we also have the package private, which is denoted by a squiggly line. Yeah, a squiggly line, but we're not gonna get into that. Okay, now let's get into designing our classroom here. All right, so if you look at here, the classroom has a name, so let's give it a name. Okay, let's just get rid of everything here. Now, here we have two options that we can do. We have a name, just like that, which is type of string. Okay, this is how you denote a data type, string. Or we can have this. Alright, so question is, which one should we use? Well, easy answer there is we would usually use the private one. The one declared as private. Why? Because if it's declared as public, anything, even those code, code outside of the class can access the instance and directly change its name. That's not what we want. Okay? We would like some validation function to change the name for us. That's why we're going to leave this as a private variable. So name string. What's next? Next, you got a homeroom teacher. Okay, homeroom teacher. So that's also private. So homeroom teacher. String, of course. Oops. Okay. Next, we got the list of students. Alright, so this is where it gets fun. Okay, let's declare this first. Students. Okay, if you notice, I'm using camel case. Camel casing is, variables start with the small letter, and then if it contains more than one word, each subsequent word starts with a capital letter. Okay, so students will be student array. Or better yet, an array list. So we don't have to deal with arrays much. So student. Alright, now what's the difference? Look, we have a capital S here for the student class. In Java naming conventions, if we're naming a reference type, such as a class, we would usually name it with a capital S. Because, of course, is a reference type, which we're going to disassociate from our primitive types, which start with a small letter keyword like int, string, not string. String is a reference type. Int, double, boolean, and whatnot. Okay, so we have an array list of students, and next is that's it. All right, what other characteristics can a classroom have? You know, for simplicity's sake, for this stream, let's just keep it at those. Okay. All right, let's continue. So next part we have here. Okay, this is where we declare our methods. Okay, so the first type of method, well, maybe arguably it could be called a method, or it can also not call it a method, depending on how you would like to call it. I'm not too sure in this case, but first we have the constructors. So basically, constructors are okay. Let's call it a method. Constructors are methods that get executed whenever a class is initialized, or when a class is instantiated, rather. So simply to declare a method, to declare a constructor in UML, you would just use UML in Java, and I'm pretty sure also with other programming languages. When you declare a constructor, you use the class name. So that's classroom. Okay. So by default, constructors do not have a return type. They always don't have a return type. Okay? Nor a data type. So that's why it's just pretty much like that. Okay. So alright. So next thing we are going to do here, okay, we are going to create our constructors. Now by default, Java has default values assigned to each data type. So if you don't have a constructor, you don't have an explicitly declared constructor, Java's gonna give names or values to your instantiated variables, like these ones here. So if you don't have a constructor, name is automatically gonna be null, a null string, a string that doesn't contain anything. So it's a null reference type. Homeroom teacher is a string, so it's gonna be null again, and students is gonna be null again because, well, it's a reference type. But if it's an integer, the default variable or the default value Java will set it is 0. Or if it's a float or a double, 0. Or if it's a boolean, it's false. So on and so forth. Alright. So, thankfully in object-oriented programming, we have this thing called overloading. Okay, so you can declare a lot of methods with the same name as long as their parameter list is different. So that's what you call overloading. Alright, so for our classroom, I guess it's a better idea that the moment we create a classroom, we give it a name. Okay? So we give it a name. So the constructor accepts a name, which is a string. Okay? So when you call a constructor with a single string parameter pass, it will call this first constructor. Okay? Java cannot distinguish constructors using the name of their parameters. Rather, Java distinguishes the constructors using the order and the amount of your parameters. So, if we create a class, or if we create an instance of this class, and we want to give the homeroom teacher name, or simply teacher will work, teacher, like this. Java cannot tell the difference between these two because you're both passing a string. So this is going to be ambiguous type error. So the Java compiler is going to complain with this. Okay, so I guess next we can declare a classroom with name and teacher. Will this work? Yes, it will, because again, single parameter, double parameter. Okay, so Java will not see them as the same thing. Okay. Another one that we can declare here, I guess, is... Okay, let's not make it too complicated, and maybe we can stay with these two. Okay? So now we're done with the constructors. The next thing that we would like to do here is we would like to have our functions. Okay, so when we're talking about a classroom, what would we like to do for a classroom? Let's call this classroom functions. What would we like to do when we're inside a classroom? Okay, first we would like to know who the students are. So we would be grabbing a list, a class list. Okay. Next is we would like to know who the homeroom teacher is. So we would be grabbing the homeroom teacher name. What else? We would like to know maybe the class general average. Okay. So that's basically we're gonna get the average of all these grades here. So what we can do is for each student we can have gen average. Okay, let's see if this kind of design would work later. Okay. What else? We can search a student by name. Yeah, maybe we can do something like this. Okay. So those are the classroom functions. So let's design this. Now who the students are, we would like to get, okay? We would like to get the students. So class list, so we would like to get the class list. Or yeah. So it accepts no parameters because you don't need a parameter when you get a class list or when you want to get the full class list. So get class list, we're going to return an array of students. So students array. Okay. Next, we can have an overload here as well, a get class list. But this time, we limit the number of entries that we're going to return. So of course, it's going to give us this. Now, why is this allowed? Because again, there's a difference in the parameters. There's no parameter here, but there is a parameter here. So that's Java sees that as two different things here. Okay. So next, what else would we like to do with the classroom? So let's label this as check for now. Who is the homeroom teacher? Okay, so we would like to get the homeroom teacher. Get teacher. Okay. So it's gonna return the string, the name of the teacher. Okay. Next is the class general average. Okay. Get gen av. And when you're talking about general average, we're usually talking about decimals. Hence, we're going to deal with a double. Okay. A float or a double. Any will work fine. Search student by name. Yeah. Okay. Get student. And we would get the student by the student name as a string. Just like that. And we're going to release a student. Instance of a student. Okay. So yes, we're going to return an instance of a student. And I guess this is what we're going to do. Now, when designing this class, we also have to take into consideration some of the things that the object parent or the object class has for us. Why? Because when we declare or when we define a class in Java, it's inherited from the object class. Now, if you would like to know, the object class is actually, well, a reference type by itself, and it has its own functions. It has its own methods. So two such methods are the equals method and the toString method. Now, these two methods, we would like to override them because we would like to use them for our own purposes. So that's why we would declare here some public methods here, which we would override toString. Okay, we want to get the string of this the string of this instance, and we would like to have our equals, which is of course a boolean. Okay. So those are the things that we need to override because we would like to use these two functions here to determine our comparison, I guess, or if you would like just to display the classroom in string. Okay. Now, oh yeah, we should also get the name, the classroom name. Get class name. This would also return a string. Alright, so we have a set of getter functions. Now these functions simply return one of two or how many of our class variables or instance variables. But how do we set these? That's where setters come in. Okay, so we're going to set these variables. So you have a set. Okay, so we're going to set the class name, which is already going to be preset here, but if we want to change it, we can simply do something like this. Okay, and that's a void because it doesn't return anything. We can set the homeroom teacher name, set teacher name if you want to change it. So new name. Okay, returns a void. And we can, should we allow importing of students? I don't know. That might be complicated for our class here, for this specific application. Now we've designed the getters, the setters, the constructors, and the override methods. Now, the last thing that we would like to design here are our helper methods. Now, helper methods are simply methods that are private. Okay, they're declared as private, so code outside this class cannot access them. So what they're usually used for is, to help the processing that's to be done by the class. So stuff like, is the name valid, or calculate grades, get the summation of grades, stuff like that. But looking at our class here, there might not be anything that we might need to do here. Yeah, I don't think there's anything that we need to particularly do for helper functions or helper methods. All right. Now, next thing, we're going to declare the student class, because of course we still don't know what's in a student. So that's what we're gonna do now. So we're gonna add a brand new diagram right here and name this student. Okay, so we're just gonna erase this. Ba-boom, ba-boom. All right, now let's go back here. Maybe we're gonna omit this just for the sake of simplicity of this project. Okay. All right. Maybe we can also omit this because we can calculate the general average given we have all the grades. Okay, we can omit that. Okay, so students, we would like the name. Okay, so the student name, which is again declared in private, which is of string, and list of subjects. Okay, subjects. So that's subject class. So as you guess it, we're going to define another class called subject. Okay, so next is we need our constructor. Student, of course, we're going to copy the name. So we would like to create a student. We would always have a name for the student. We cannot create a student without a name. Okay, and oh, I forgot. The most important part here is we need to be able to add a student. So that's why we're gonna have our add student here, and of course we're gonna get a student name here, just like that. Void. Okay. All right. So we can declare a student, or we can construct a student using its name. Okay. Then the next thing here is, do we give it a specific list of subjects? Yes. Yes, we can. We can have that constructor here. So student name string, and we're gonna give it subjects, which is subject array, an array of subjects. Okay, that's gonna work, but I don't know if we want to implement that. That's kind of complicated to implement anyways, or maybe not. So next, our getter functions. Let's create a get name. So we're gonna get the student name, so that returns a string. We're gonna get the list of subject. Okay, that's going to be a subject array. Oops. We can also get subject list with a particular limit, so n entries. So that's going to be again a subject array. Alright, and what else? I think that's all. Yeah, I believe this is all. Okay. We can get get a particular subject, I guess. Yeah, subject name. Just like that. And we're going to return a single subject. And we can do a get average. And I'm going to return a double here. Alright, and what else? We can... What else can we do with the student? Grade the teacher. I think that can be set itself. Okay, I believe that's gonna be fine. So next, the setters here. So we're going to set the name. Whoop, and give it a parameter of the new name. String, and we'll return void. We can add a subject. Okay, let's just add subject. Okay, and we're gonna pass a new subject to it. So subject. Okay, notice the subtle differences in capitalization, because the capitalization is going to tell you what reference type it is, while the ones that start with a small letter, they're variables. Okay, that's a popular Java naming convention there. Okay, so we're gonna add subject. What else can we do with a student? I think that's all. Of course, we would like to also declare our override or overrides here, which is I don't know if we're going to need a toString, but let's just put it here for now. Okay, and we might need an equals. Alright, so let's deal with this first. Next, we have a subject. So we need to declare that class as well. Whoops, that's not what I intend. Alright, let's name this as subject. Okay. Alright, let's see what next thing we can do here. Okay, so for subject, let us have our subject name. Okay, so we have our subject name. That's a string. We have our grades, or a grade for that particular subject, which is a double. Okay, next is the teacher for that particular subject. Teacher name. Oop, Chinese keyboard. Teacher name, which is a string. Okay, we're not dealing with arrays here, so that's sweet. Okay, now constructors. Subject. Let's see. What should we have for a subject here? How do we create a subject? What do we need to create a subject? So we would need, of course, the subject name, string. We can also add another constructor here where we can pass our subject name and our teacher name. Okay. And yes. Now for getter functions, we can get the subject name. So for this one, of course, it's string here. This one is get grade, which is going to be a double. This is going to be teacher name, so we're gonna get teacher name, which is going to be a string. Whoa, I forgot the invoke. Okay, so that's for getter functions. Next is, what else would we have next? Okay, so when we get our teacher name, we would like to set. Okay, because we're constructing this class without a the grades. Okay, so we need to find a way to set these things. So we can set name if we want to make a new name for it. So that's gonna take in a subject name parameter. Okay, that's gonna give us a void, and we can also set the grade, which will also new grade, I guess. So that's gonna be a double, and it's gonna give us void, and we can set the teacher just like this, and new name, is equal to string, or is a string rather, void. You know, in the real world, sometimes these aren't void, and these are booleans, because we would like to tell the function caller whether or not the operation was successful. You never know. You might have a dynamic memory allocation error, a null pointer exception, wherein you would like to return with a false or something like that, or integer if you would like to return a specific error code if you're into that kind of thing. Okay, which is well, technically it's something that you would like to do because it makes debugging easier. Okay, what else? I think that's all. Again, our overrides here, toString and equals, which is going to be a boolean. Okay, so I think this is good enough for our design. We can of course change some stuff here, but the less revisions, the better, because that way we can properly implement our program in code. Okay, so let's see what we can do here. Okay, now let's open our IDE and actually start the coding. So let's create a file here. Let's call this the main, or the driver, because this is what we're going to use to test our code. So a couple of files here. Let's have our driver file. So this is going to be our, let's call it a classroom driver. Okay, so this is where the magic's gonna happen. All right. So do note in Java, if you're new to Java, usually your class name has to be the same as your file name, and because it's a reference type, because it's a class, it has to start with a capital letter. Okay. Oh, I was showing the wrong screen here. Okay, so we have a classroom driver.java here. Okay, as I created earlier. Next is we need preferably individual files for each of our classes. So we have our subject class .java. Okay, subject.java. We have our classroom.java. Okay, we have our student.java. Okay, so 3 files that we're gonna try to implement tonight. Okay, let's do this. So we're gonna start with I don't know which approach is actually better. So let's see. I think this is going to be another learning experience for me as well. So we're going to start with the student. Okay, let's go from right to left here. Let's try doing it that way. So let's start with student. So let's refer to our UML diagram. So a student has 3 instance variables. We have the subject name. Oh, I'm sorry. We're starting with subject rather, not student. Okay. So we have 3 instance variables here. The subject name, the grade, and the teacher name. So let's declare that here. Again, okay, let's just place some comments here. Let's see if we can do some Java doc comments. Okay. So, okay, you know what? For simplicity's sake, let's just use ordinary comments. Okay. So subject name. So we're gonna do the first part of our class. We're going to declare our instance variables, and as you can see, as per the design, these are declared as private variables. So we're gonna declare them as private. Okay. So private string subject name. Okay. So we're not gonna set a default value for that. So the reason why it's warning is because it's not used. So we're gonna use them later on. Okay. Next, the grade. So private double grade. Okay. Next, teacher name, which is a string. So private string teacher name. All right. So next, let's develop our constructors. Okay. So, all right. For the constructors here, ooh, seems like I'm dropping some frames on YouTube. Hopefully not. Anyway, for constructors, let's implement these as follows. So, subject, the first constructor only accepts a string of a name. Okay, so let's implement that. So public, the way you do a constructor, as again, it doesn't have a return type, so we don't have to put a return type or anything. We don't have to put a return type. So public class name, which is subject in this case, and then we give it our parameter list. So that's a subject name as a string. So string subject name. All right. So as you can see, we're giving it a name, and we want this particular name to be the value for our instance variable. Now, if you look down here, we don't actually have to code it in the constructor because we have this function here, which does it for us. Okay, so that's the beauty of UML design, because you can see what you can use and what you can't use, I guess. So let's call the set name function. So we want the set name to subject name. So right now it's flagging an error because it doesn't have a definition for set name yet, which we will do later. Okay, next constructor is basically we're also giving the teacher name. So that's string subject name and string teacher name. Now here's the beauty of constructors. You can actually call a previous constructor. So we can do something like that. But we're going to use the this method. The problem with this is you can only call it, you can only invoke this within constructors. Again, you can only call another constructor within a constructor. So that's what we're going to do. So we're just going to pass a subject name. Okay, so what this does, it calls this constructor which sets the name for us. And then after the name is already set, this is when we can set the teacher name. And as per design, we have a function called, or we have a method called set teacher name. Alright, so we're simply going to call that method here, and we're going to give it the teacher name. Just like that. Alright, after coding the constructors, the next thing we need to code are our subject matters here. So get subject name. So we're going to code our getters. Getter methods. Let's not sound mad. Getter methods. Okay, first, it's declared as public. We're gonna get the subject name. So public get subject name. So it's a void. Oh, sorry, forgot the return type here. It returns a string because we're returning the subject name. Void, it doesn't have a parameter within it. So it doesn't. The reason why we have getter functions is we would like to do some validation. Like for example, if we want to get a subject name, we need to have like some sort of security protocol or anything. That's why we can't exactly set these as public, because anyone can change the values because they're directly accessible from outside the class. That's something that we would not like to do. Okay, so what we're gonna do is we're simply going to return the subject name. But ideally, we would have some logic here, some validation logic that would validate that the user or somehow an external class is actually allowed to get the subject name. But for this particular application, we don't really need to do that. Okay. Next getter method is we have the get grade. So public, what's the return type? Double. Public double get grade. Whoop. All right. So when we're gonna get the grade, simply, we can actually, okay, let me change this design here. Not a subject, but an array list, just to make our life easier. Array list. Whoop. Okay, that's just gonna make our life easier. Anyway, so we're gonna get grade. We're simply going to return the grade. Okay, so return grade. All right. Next, we have our teacher name. So public string get teacher name. So we're simply going to return the teacher name, just like that. Okay, so again, we will always have some validation, like is this a valid teacher name? Is this a valid grade? Before we return them. Okay, that's important because we really do not want this to be exposed to the public. That's what you call abstraction. We're hiding these stuff from the user so that they're just gonna make their lives easier and use these stuff, right? That's how you design a class. Next, we have the setter functions. So setter methods. The first setter method here, we have our name. So public set name. Whoop, forgot the return type here, which is a void. Okay, public void set name. So we have our parameter, which is the new name. So new name. And what this is going to do is we're going to change the subject name into that new name. So that's simply going to be subject name is equal to new string, okay, and new name. Easy. All right. If you don't want to declare a new string, you just set it straight to new name. Okay. Next, public void set grade. So when we set the grade, that's simply double new grade. So that's going to be grade is equal to new grade. Okay, we don't need to declare some sort of new instance here or anything, because again, double is a primitive type, so it doesn't need any instantiation. Okay. Next, we have the set teacher name. So public void set teacher name. Alright, so that's going to be string new name. Alright, so again, this is not going to conflict because it's a separate method. So that's going to be teacher name is equal to new string new name. Alright. Next, okay. Now here is the overrides. Here are the overrides. So again, Java classes, user-defined classes inherit from the object class in Java. So the object class has these methods that we can override. So let's override some of them. So when we override a method, we would declare it like this, right before the method name, okay, or the method declaration. So public string to string, just like that. So we override this ourselves. So okay, what would we like to display or give back the user if we are going to declare, or we're going to let the user get a string of that specific subject? Maybe we can return some sort of string that summarizes everything that's about that subject. Okay, so alright, here's my idea. We can return us a simple string here, a concatenated string. Maybe you have a bracket here, and we can maybe put the subject name here. Yeah, we can put the subject name here. Subject name, just like that. What else? Let's have a space. We can have the teacher name here. So teacher name, just like that. And then let's have this straight line thingy here, and put grade is equal to, let's add in here our grade. Okay, so the thing with grade, it's not a string, so we might be flagged for an error if we're going to try and concatenate this here. So we can use the string class. I don't know if we have the specific double. Okay, we do have it. So value of a specific double, which is our grade. So that's going to be a string now. And yeah, I think that's all. That's actually it. Okay, so we're going to return a string that has the subject name, the teacher name, then the grade. Summary of data. Okay. Next thing on our design, we have the equals. So we have to check if two subjects are equal to each other. So that's simply public boolean equals. We will have an object here. Okay. So firstly, we would like to check if this object does exist. So if obj is equal to null, of course you would like to return false, right? Because it doesn't exist. So of course we would like to return false. Okay. Next thing, if the object is, or if the object does exist, what we're going to do here is we are going to invoke this into a subject class. So let's try doing that. So we're gonna declare a subject here, and we're gonna name it subject, or the comparison, I guess we can name it comparison, is equal to, okay, we invoke type subject, or we cast the type subject to object, just like that. Okay, so we're casting that if it doesn't exist, that is. So now we have a copy object, or a copy comparison, which is wherein Java thinks that object is of type subject, of the type of the reference type subject. So now we can do our comparisons. So when is a subject equal? So that is when if comparison dot subject name is equal to, or this is a string, so we can do an equals here, equals, let's see, the subject name and what else? It also has to be equal to the teacher name. Okay, so teacher name, comparison dot teacher name must be equals equal to the what do you call this? Equal to the teacher name of this instance. Okay. Now, here's the thing. It's up to the designer or the programmer in this context if we would like to compare the grade. Okay, if we would like to compare the grade for this particular subject, it completely depends on what your definition of equals here is. Do you like to compare the grade as well or not? You just want to know if it's the same subject. So for this context, let's just say we don't want to we don't want to compare the grade. So we're simply going to return true. Else, we're going to return false. So that's our override. So we're done with the subject class. Perfect. That's done. Next, let's deal with the student class. Okay, give me 1 second. I just need to take a small break because I just want to. Just to reply some stuff on Messenger here. Okay. Wait, give me 1 second. Okay, let's continue. Whoop, wrong window here. Alright, let's continue here. So, student. Let's go back to our design for the student here. So, we have two private variables, namely our name. So private, again, let's copy that structure here. So we have our instance variables. So we're gonna have here our private string name. Oh, small letter. What else? Alright, this is where it gets interesting when we deal with our data structures. Alright, so private array list. Okay, so array list of what? Array list of subject. Okay, so we declared that object. Array list of subject of, let's name it subjects. Alright. Now this one, we're going to have to cast this later when this gets compiled here. Okay. So that's why it's showing an error, because this class, the subject class, isn't compiled into a .class file yet. So that's why Java currently cannot see the subject class. Okay. Next, we have, I believe that's it. Yes. So time for our constructors. Okay. So constructors here. Get name. Oh, sorry. Constructor. Student. Now, again, what do we need when we create a student? So based on the design here, we need a name, a student name. So string student name. So we're gonna simply set name is equal to new string of value student name. Perfect. Next constructor, we also have the list of subjects. Now this is kind of complicated. Public student, maybe not complicated, but very tiring to implement. Yeah. Okay, so we're gonna get first the student name, and then we're gonna get the array list of subject list of subjects. You can call it that. Okay. Again, it's showing this error because it is not compiled yet. We did declare this as a public class. Okay. Alright, so again, same technique as earlier. We're going to call the previous constructor student name just to save us some time. Okay. And then we are going to set our subjects array list equal to the memory address. Okay. Or we can declare also a new array list, which might be safer in some security standpoint, but okay, there's a huge caveat there. It might, depending on the number of inputs you're gonna handle, it might affect your program performance. All right. Yep. Okay. So array list of subject, and we don't have a constructor for that, do we? Okay, let's just declare it as the subject list here. Okay, just like that. Yeah, cannot be resolved to a type. Just wait for that later. Anyway, next we have the name. Okay. Oh wait. I'm sorry. Subject array. Okay, that's how we designed it. So it has to be an array of subjects. Okay. Subject array. Subject list. Okay. Now this is going. It might declare an error here because these are not the same type. This is an array of subjects, while this, my friend, is an array list. So that's not okay. So let's implement this properly. So what we're gonna do here is a simple algorithm, a simple loop. Now for each, Java. I don't know if Java has a for each. Okay, I'm new to this. Now for int I is equal to 0. Okay, we're gonna assume that the subject list is full. Okay, it's full. Just for simplicity's sake, we're gonna assume that subject list is full. We don't have any empty elements there. Okay, so I++, we're gonna increment that, and we are going to add to the constructor. We need to declare this. We need to instantiate this new array list of subject. I forgot about that. We need to instantiate this just like that. Okay. Subjects with an S. Okay. Anyways. Okay. So we're simply gonna add. So to the subjects array, subjects.add, and we're gonna add subject list I. Okay. I hope this makes sense. The indexing. I hope that makes sense. Right. I believe that's gonna be fine for our next constructor. Next, we have our getter methods. So for getter methods here, we have the get name. So public string get name. Okay. Nothing much required there. So when we get the name here, we're just simply going to return the name because we don't have any validation. So that's gonna be fine. So we're just going to return the name. Okay. Next, get subject list. Okay. So public subject array. Is it a subject array? Yeah. Subject array. Get subject list. Okay. So when we get the subject list here, we simply return. Okay, we need to transform. We need to transform the array list into an array. Now the question here is, is there an API to do that for us? Yes, I'm sure there is an API that does this for us. So you can do the API work here, which I'm not going to be doing. I'm going to do it manually because I don't have any APIs from the top of my head that does this for us. So we're going to do this manually here. So for int I is equal to 0, I is less than subjects dot size. Yeah, okay. So you have to invoke it. I plus plus. Okay. So we're gonna get that element. Okay, I get it now. So we are going to declare a new array here. So subject array, temp array. We can declare something like this. Okay, and we're gonna create a new subject array, just like that. I don't know if that's a thing though. Yeah, the constructor is undefined. Okay. Whoops. Okay, new subject array. Okay. Type mismatch, cannot convert subject to subject. Again, probably because it hasn't been compiled yet. Okay. Next. Or did I have it backwards? I think I have it backwards. No, I don't. The type of expression must be an array type, but it resolves the subject. Oh, okay. Okay. Anyways, all right. So we want to add. We have to create this array here, where the size of this array is simply going to be subjects.size. Okay, because again, arrays are not dynamically allocated, unlike array lists. Okay, now temp array, element I of temp array is going to be equal to subjects. Oh, sorry, no, it's not gonna work. You have to specify dot get I. There we go. So that should work, and then after that we're going to return the temp array. Okay. Hopefully this gets resolved later when we do some compilation. When we finally do the compilation. Okay. After get subject list, we have another one, get subject list. We're just gonna copy this because it's pretty similar, and this one gets an integer of entries, so int n entries. So we're not gonna deal with the size anymore, but we're gonna use n entries here. Let me space constructs. Anyways, there, like that. Hopefully that resolves later. We're gonna solve that later. Paste that there. Alright, so the loop's gonna run for n entries. Okay. Next, get subject. Okay, so we want to get a subject from the student. Okay, this might be a bit complicated. So public subject get subject, and we're gonna have the subject name as our parameter. Okay. So when we get the subject here, what we're going to do is we're gonna research, or we're gonna loop through the array list and check if specific values, which is basically the name, is gonna be there. Okay. given just the subject name. So we can do that via just a simple string comparison. Okay. Let me give me a second here. Okay. Don't have any frame drops. That's good. Alright, anyway, let's continue. Okay. Now, when we're gonna get the subject, we need to loop through the array list and see if the string is going to be equal. Okay? Yeah. Okay. Looks like we might not use the equals here because we're not really comparing it to another subject unless we want to unless you want to explicitly compare, but it's good to have that. Anyways, so we're gonna get the subject, we're gonna compare, find this specific name in the loop in our array list. So simple for loop here, int I is going to be equal to 0 and I is less than subjects dot size, okay, and I increments by 1. Okay. Anyways, you know what? Let's just compile this. Let's open up our terminal. Okay, where are we? There. Let's just compile java student.java. So it's not gonna scream at us. So we do have some syntax errors here. Sorry, subject.java. All right. So hopefully that resolves. Okay. Okay. And maybe there's something here that I am not catching, which is a custom array list. So let's check this out. Maybe there's something here I'm not catching. Okay, so let's look at our problems here. Array list cannot be resolved. I feel like I'm such an idiot. Import java.util. Oh my goodness. I feel like I'm such an idiot. Why? Oh gosh. Such an idiot. Alright. Anyways, let's go on here. I feel like I'm such an idiot. What the heck? 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 I'm such an idiot. Okay, anyway, let's not delve into that and continue with our coding here. Totally forgot that array list has to be imported. I feel like a disappointment right now. Oh my goodness. That's fine. It's a learning experience for me. Yeah, that's why I'm doing this this stream, to learn as well as I code, because it exerts pressure onto myself, so you can learn on the spot. All right, anyway, let's continue. So, whoops, sorry. Okay. So, when we get the subject, we want to loop through the array and look for a specific instance of a subject that matches the name. So it's simply a comparison here. So what we're gonna do is we're gonna loop through, and now we want to get. Okay, we want to have an if statement here, or no, sorry. Oh yeah, an if statement here, wherein we have subject name equals, okay, we're gonna pass to the object here, which is subjects, okay, dot get I dot, what was that again? Yeah, it's here. It's down here. Get subject name. There we go. Okay. So if it's equal, we can define okay. So I'm not one to use the break function or the break statement because it promotes premature ending of loops. So we can just have a boolean here, is found, which is defaulted to false. Now for our condition here is and not is found. So when it's still not found, the loop continues. So now that we found this, we're simply gonna go and change the value of is found to true, just like that. And lastly here, we're going to simply return is found once the loop is finished. Okay. Oh, I'm sorry, it's a get subject kind of thing. Okay. Alright, then you know what? Let's just return this prematurely. We could just return it. Okay, so yeah. Alright, let's do this. So, if we found that specific subject, we can return this instance. So we're gonna return subject.get that particular I. Sorry, subjects. Okay. Else we are going to return null. Okay, so that's simple. Next, where are we? Okay, student class. After we're done with get subject. Oh, it's here. We have our get subject list, two constructors, get subject, get average. Okay, so public double get average. Okay, so it's null. Yeah, it's null. Okay. So we're gonna get the average. We just want to add up all the grades of all the of the student. So we're simply going to get the. I believe there's a sum function here that we can try and see later. Sum of, but that might be Python. I might be sorry, I might be mistaken. Okay. Now, we're gonna declare some variables here. Double grade sum. Initialize it at the 0. Okay, so now we're gonna have a for loop. Int I is equal to 0. I is less than the subjects dot size, and I iterates or increments rather. Okay, so we want to get the sum. So the grade sum is going to increment by the subjects dot get particular I here and get grade. Okay, so see how everything kind of fits in when we deal with object-oriented programming. It all fits in. Okay, now we got that set. Grade sum is plus equals subject. Okay, now we want to return grade sum divided by a specific number here, which is our subjects dot size. Okay, because we want to get we also want to cast this as a double. Okay, so we don't have any type conversion errors here, so we're gonna explicitly cast this as a double. Okay, because this is the number of subjects, right? Next, after get average, we have our set name. So we have our setter function. It's just one function, setter function. Okay, so for the setter function, we only have one. So that's public. Whoop, Chinese keyboard again. Public void set name. Did I get that right? Yes, set name, which is being called up here, I believe. No, it's not. We can just call it here. Set name and pass the student name like that. Okay, so I'll void set name, and of course it has a parameter of the student name. Alright, now let's set the name for this thing. So of course we're gonna do some name validation, but for our specific application it's not needed to do. So let's go ahead and set the name. I think it's called, for this class, name, just name, is equal to new string student name. Oh, there we go, easy as that. Next, add subject. Okay, so yeah, I guess you could call it a setter, I don't know. Add subject. Okay, so for this one we are going to get a subject variable and call it new subject, I guess, because why not? So this is simple. This is simply subjects. Okay, this is our array list. Add new subject. Of course, after doing some validation here, but for this this application, no need for that. And then, all right, overrides. Override. Why is the Chinese keyboard popping up? Oops. Alright, so we want to override the toString function. Public string toString. Okay, so when you override the toString function, what do we need? We don't have any parameters needed. Now, this is a student. What can we do when we submit a toString for it? One idea that I have is we can give a string representation by, I don't know, maybe returning a JSON string, but that might be too wide for this application. So let's just give the name, I guess. I think the name can suffice, the student name. Maybe the student name and the grade. That could work. Okay, or average rather. So return student name. Okay, student name. Name. Okay, return name plus, what else? Let's return here string, plus a space, a colon and a space, plus string dot value of double, which is get average. Okay, perfect, something like that. And then last for this is override public string equals. So you want to see if an object is equal to this student object here. So first of all, object must exist. So return false. I am so sorry. Why is this string? This is supposed to be boolean. Man, I'm sleepy. Really sleepy. Anyways, so now we're gonna cast it. So student comparison is equal to a cast of student. Data type casting, student of obj. Okay. Now we want to compare if the student name is the same. Student name, and I think the student name will suffice. So if comparison dot student name, or dot name rather, dot equals name, return true. Otherwise, return false. Alright, I think a simple comparison like that's gonna suffice. Okay, next. The most stressful one, the classroom class. Okay, because it's the longest one. Oh, that's so long. Oh gosh. Okay, let's zoom through this. Let's zoom through this. Give me 1 second. I need to take a really short break. Ah. Man, I'm a bit sleepy. It's alright. It's alright. Sanitize your hands, people. Sanitize your hands. Man, I can tell this stream might not be like the most efficient one, because I'm just getting into YouTube and I want to try and experiment what kind of approaches to teaching or what kind of approaches to experimentation is gonna be good for. It's gonna be effective for viewer pleasure, and not just viewer pleasure, but also making the viewer learn as I go, because that's my goal, is to help people learn while I learn myself. Because again, I'm a computer science student. I'm in no means a professional, at least not yet. So that's why I would like to kind of learn as I would like people to learn as I learn, because I believe that's an important thing. Because if another way of learning is teaching. Alright. Or personally, I like rubber ducking. So if you know what rubber ducking is, basically you just talk to a wall about your thoughts, and it clears up your thoughts and everything. So anyway, let's get back into it, shall we? Okay. So, all right. Let's get back to it. Okay. Let's start. Private variables. You got our name, homeroom teacher, and our students. All right. So let's get back here. Let's not make the same mistake as earlier, and actually let's import the Java util. Okay. Alright, so let's declare our instance variables. So we have here our name. So private string name. Our homeroom teacher. So that's private string homeroom teacher name. We're not necessarily going to specify the name there. Just homeroom teacher will do fine. And then the array list of students. So private array list of students. Student rather. Okay. Let's name it students. I think that's how it was named. Yes, that's correct. Alright, constructors time. Okay. Classroom. So public classroom. That actually sounds nice. Public classroom. The classroom is open to the public. Alright, so string name. Alright, so this is one thing I'd like to highlight. Look at this. It looks like some sort of naming error here, or a naming conflict. So let's try to get around with this when we're setting the name. Okay, later, because we actually don't have a set name here. Oh, we do, set class name. So let's just call the set class name and pass to it the parameter name. Alright, how am I sure that it's taking this parameter and not the instance variable? Because it takes the closest one to it, which is this one. If you would like to refer to the instance variable like we will do later, you would refer it to this .name. Because what this means is we're referring to this instance name. The name of this instance. Okay? So that's basically how it means, or how it is. Next constructor, name and the teacher's name as well. So public classroom, string name, and string teacher. Whoop, why is it a semicolon? Just like that. So simply we're going to call the previous constructor and pass name. And we're going to set the teacher's name, which is here. So it's set teacher name right there at the bottom. And submit or pass the value of teacher. But did we do that here in student? Oh no, this one had to be done manually. Alright. So, next, we have here our methods. Firstly, we have our getter methods. Getter methods. So for the getter methods, public, public, really. So public, get class name. Public string, get class name. And no parameter for that. So we're simply going to return the name. Okay? Next, class list. So we want to get a class list. Okay. Public array of students. The student array, get class list. So simply being done here, we are going to do the same thing that we did here, which is we are going to get the subjects here. Okay. So let's head back here. Classroom. Okay. So we're going to declare a new array here, which we have the temp list, I guess. Oops. Student temp list is equal to new student array of size array list. So size students dot size. Just like that, my friends. Okay. Next, we are going to have our for loop here. Int I is equal to 0, I is less than students dot size I increments. And then, okay, next, we're gonna populate the array. So temp list I is equal to students dot get I. Okay, so we're simply just duping it, the array list, into the array. And then lastly, we're going to return the address of temp list. Now for the next function, or the next method, it's simply an overload of this, but we have our n entries. So a particular number of entries here. So we're no longer going to use students.size. Okay, but we're going to use n entries. Just like that. And that's done. Next, we have the get teacher name, which is very simple. The public string get teacher. No parameter needed for that one, and we're just going to return the homeroom teacher name. Okay. Next is the general average. Okay, now this one might need some thinking. Get gen av, I think that's the name. Yeah, get gen av. So what we would like to do is we would like to iterate through the averages of each student, and we are going to add them all up. Okay, so we're gonna have the average sum first, av sum. So that's why we're going to declare a double av sum, which is 0, and another for loop. And I is equal to 0, I is less than what? I is less than students dot size I increments. Okay, so what we're basically going to do here is we are going to, let's see, what are we gonna do here? I'm losing my mind. It's almost 1 a.m. in the morning. I should really do these streams at an earlier time of day. Anyways, so we're going to get the general average of each student. So av sum plus equals students dot get ith element dot get average. That's way simpler than I thought. Okay, and then finally we're going to return the av sum divided by casting the double students dot size. Okay, that was way easier than I thought. Okay, next is get students. Okay, so we're gonna get the student name, or get a student instance depending on a student name. So public okay, there's something we need to fix we don't want to return. Okay, actually, okay, we're not gonna deal with much of the security for this application, because we wouldn't like to return ideally a student instance, but a copy of that instance. But for simplicity's sake, let's just return it. Let's just return the instance here. Get student. Yeah. So string student name. Whoa, 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 whoa! Check your spelling, Addy. Okay. All right. We iterate. Everything solved by iteration. Oh my goodness. I is less than students dot size again, and I increments. And again, we're going to have boolean here. Boolean found. It's equal to false. Man. Okay. So basically, going to iterate and check if student name dot equals student dot get the ith dot get name, then found is equal to true. Now, of course, we have to deal with the problem of students having multiple names, but for this one, let's not do that for now. Whoops. So we're gonna have and here and not found. Okay. So we're getting the student. Okay, so we're getting the student, so we don't need this. Why am I tripping over myself? Okay. Return students dot get I. If not, we return a null pointer. Okay, next. Add student. Now this is fun. Setter methods. So public void add student. So when we are going to add a student, we are going to get a student name, okay. All right, so it's the same kind of logic here. When we added a subject, we are basically calling the constructor here, because when we added the subject, where's the add subject here? Oh, sorry, in the student file. We were passed a new subject, which is of course created by a constructor, which we're not gonna deal with in this class. Okay, so I think I see what happened there. So we're gonna do that same thing here, because but okay, here's a huge but here. If you look at the design, add subject, you're passing to it a subject, but for this one, add student, we're passing to it a string. So we're not dealing with an object, we're dealing with a string, so we're gonna have to deal with the constructor. So when we're gonna do this, we're gonna go with subjects dot add students students dot add. We're gonna call the constructor for a student, okay, or a new instance of a student, and then we're gonna call the constructor like that. That should make sense to the compiler because we have a constructor here that accepts one parameter. So that's gonna construct the student for us, just like that. The next thing I think we forgot to do here is we need to add the subject, student subject, but okay, let's not do that for now, and let's just focus on finishing the class because I'm tired. I'll probably do the rest in the next stream. So add student, set class name, so public void set class name, That's string new name, I guess. Or did I use new name? Yeah, I did use new name. I can talk to myself. Alright, so this is simply, when we set the class name, this is simply the name here is equal to a new string of value new name. Just like that. Okay? Next, we have set teacher name, public void set teacher name. Just like this, so that's going to be new name. So teacher, homeroom teacher, no, not that. Homeroom teacher is equal to new string new name. Just like that. Alright. Oh, I forgot. String. Okay. See, I need sleep. Now we have our overrides. And we're going to override here the toString function. So that's public string, toString. Now, what would we like to return? That's a good question. What would we like to return here? Whoa, okay. Where'd that come from? Okay, what would we like to return? Maybe the class name, the homeroom teacher, and the number of students. I think that will work. So we're going to return the class name. I think somehow something like this. Okay, so class name. Okay, I think it's just name. Yeah, it's just name. Okay, name. And then we don't need a space here. Space here. Teacher's name. Oh, okay, so that's homeroom teacher plus space number of string dot value of integer, which is students dot size. Okay, students. Yeah, something like that. Override public equals. Okay, public boolean equals. Okay, so what would we like to override here? How do we denote equality in this class? Object obj. So first, of course, the object must not be null. Return false. Okay, so we can cast it. So classroom comparison is equal to cast obj. Okay, last push. You know what, we'll do the classroom driver in the next stream. For now, let's just finish this. What do we need to compare? The class name. Okay, actually everything. The homeroom teacher and the number of students, I guess, has to be equal. So if comparison dot name dot equals name and comparison dot homeroom teacher dot equals homeroom teacher, and let's do this on the next line, and what is this dealing with? Okay, and what was the last one? The number of students. Yeah, comparison dot students dot size is equal to students.size, then we return true, else we return false. Alright, I think that's it for the individual classes that we've done here. So the next part will be the next stream, where we're going to actually test these out and check if what we've done is correct. So again, just a quick review. What we've done is we followed the design. As you can see, there wasn't much design errors. Like, we didn't need to think of what we would need to do on the spot while we code, because everything was already planned beforehand. Now that's what we strive to achieve. Everything must be planned beforehand, because that makes everything easier in implementation. So you don't have to deal with, or you don't have to worry about changing your design midway. Okay, so this is a really good help. So one thing that we didn't get to tackle here are what we call helper methods. So helper methods are usually declared in private, and these helper methods maybe convert some grade to GPA or something like that, and then it's not accessible by the public or by other code, but your public codes or your public methods can use it. Your class methods can use it and help to achieve some stuff. So it's pretty useful. Something you could use when you decide to code using this style. Okay. Anyways, I think that is it for this stream. Thank you so much for watching. Hopefully, this next stream will be better, and I'm not sleep deprived. But I'm a computer science student, so I don't know when that's gonna be. Hopefully soon enough. But anyways, that's for this stream, and ciao. Thank you for watching.